Okay, so the second question we looked at was a bike manufacturing company has two plants P and Q. Okay, plant P manufactures 60% of the bikes and plant Q manufactures 40% of the bikes. 80% of the bikes at plant P is what is of standard quality, and 90% of the bikes at plant Q are rated of what standard quality. A bike is chosen at random and is found to be of standard quality. Okay. What is the probability that it has come from what plant P? So we are trying to find this. Okay, probability that it is coming from plant P, given that it is what of standard quality. So as usual, we would have to write out the information given us. So we have this 60% of the bikes coming from plant P, and we can also represent that as what probability. Probability that it is standard and coming from plant P will also be what 0.8. Okay. We have probability of the plant or the bike coming from plant Q to be what 0.4, which is the same as 40%, and we have 0.9 to be the probability that it's of standard quality, given that it is coming from what plant Q. So based on this information, we've been asked to find what P given S. Okay, so based on this, we would have to find a shorter way of arriving at the answer. Okay, so we can have this to say that plant P given S will be the opposite. Okay, S given P times probability of P over probability of S. Okay, so how did we arrive at this? Okay, so easily, let's try to illustrate how we arrived at this. We have plant this side. Okay, so from the previous video we realized that whenever we have whenever you have probability of A given B, the same as probability of A and B over probability of what B. This is based on what we've done previously. Okay, so what if I have probability of B given what A? The same way probability of A, probability of B and A over probability of what A. So based on this, we can easily find the opposite of this. Okay, because the opposite of this, which is this. Okay, and how do we get that? This is because there is an expression that is common between these two equations. See, this one is equation 1, this one is what 2. Okay, there is an expression that is common within these two. So let me rewrite this so you understand what I'm trying to say here. So we have probability of A given B to be what? Probability of A and B over probability of what? B. Okay, that probability of B given A to be what? Probability of B and A to be what? Probability of B. A, sorry. A. Okay. But we know that probability of A and B is the same as probability of what? B and what? A. Okay. So based on this condition, we can compute or we can equate these two. Okay, so when I do my simple evaluation here, you realize that probability of A giving B will now be equal to probability of what B giving A, probability of what A over probability of what B. So in actual fact, I just did the cross multiplication here. Then instead of writing the probability of A giving B, I just replaced it by this. Okay, by this, which will be this. Okay, so based on this, we can verify that this phrase is true. So we can base on this to arrive at our answer. Okay, so based on the previous question we solved, we realize that whenever we have two mutual exclusive events, we can use the OR to ascertain our probability. Okay, so in this instance, we were given these ones, in the question, but then probability of P of S is nowhere to be found. Okay, so we would have to find this using the law of total probability. In actual fact, we are trying to say that the probability of a standard quality bike coming from plant P is not in any way related to probability of a bike being of standard quality and to be coming from plant what Q. Okay, so that's how we arrived at this one based on the previous example or the previous quiz we did, the solution for the previous quiz. Okay, so in doing that, we use this one to find this. Okay, so in order to understand this, you would have to watch the previous video and you'll be able to get how we arrived at this. Okay, so you just key the values you had in the question, then you arrive at this. Then you place this here. Okay, you place it here and then you arrive at 3 over 5 to be our answer. We can either convert this one to percentages itself and we have 60% to be our final answer. Okay, so this is the solution to the second question for the quiz.